clear, you guys. Yeah. Okay. You guys ready? Okay. Today's lesson, at first, I'm going to think it may seem kind of weird and kind of dumb, but I promise you, by the time we're done, it's actually not that hard. Okay? But my introductory piece here might seem stupid, so bear with me. Okay? Here's my first question. I've got 3 graphs on the board. Can anybody figure out how they're related to each other?
Intersect.
Okay, so they do intersect. Yeah.
They have the same coefficient.
They do. They all have positive coefficients. Okay, maybe I'm not phrasing this properly here. Could we use two of those graphs to make the third one? Could we use 2 graphs to make a third? There's some sort of pattern to it that we could use. Anybody figure that out?
X squared
You they added the x squared and the 2x plus 1 to make the top one.
Okay.
The red one.
That's kind of it. You see how this guy here is x squared? Mm-hmm. That's a quadratic graph. And this guy right here is 2x plus 1, a linear graph. If we literally add them together, hence the point operations, right? Add, subtract, multiply, divide. If we literally added them together, we would get this graph right here in red. And let me prove it to you point by point. Okay. If I took this point right here, what is its output value? Yes. Because that's its y value. Does that make sense? If we took the blue graph, what is its output value? 1 plus 3 is 4. I'm going to try this a few times. What is the output value for the teal graph? 0. Okay, the blue graph you can't see, but what's the output value for the blue graph? 1. 0 plus 1 is 1, which is the red graph. You guys seeing this yet? Okay, I'll just keep trying it. What is the y value for the blue graph? Okay. What is the y value for the teal graph? 1. Okay, we're going to add those together. So negative 1 plus 1 is 0. And you see how that's where the red one is? Okay, we keep trying. Output value, negative 3. Output value, 4. Add negative 3 and 4, what do you get? Which is where this graph is. Do you see how this works? Getting there? Yeah. I'm picking the same consistent x value and then figuring out what the y values are for it. So I'm doing it in a line, say right here. This guy is 1. This guy is 3. 1 plus 3 equals 4. Okay. What we're going to do today is we're going to work on adding, subtracting, multiplying, and dividing functions from each other, basically. And at first, like I said, it might seem kind of dumb, but it's actually not hard. Okay. Here's the way that we can write this then. Okay. If we want to write adding and subtracting functions, basically we could say this is the new output, and it's the result of adding 2 numbers together. In theory, we could also subtract them, and so here's some notations we'd use. So let me try a new example. Let's try sketching 2x minus 1. So you guys remember how to do linear graphs? What is 2x minus 1 have for an intercept?
1.
Okay, slope of 2. So here is the graph 2x minus 1. Okay, and so this one will be f of x. If you have different colors, this may work well. Everybody okay on the 2x minus 1 graph? Okay, x minus 2. Slope of 1, y-intercept of negative 2. So it's going to look like this. Does that make sense? Those are my 2 linear graphs.
What was the other one?
X minus 2. What we're going to do now is we're going to add the output values. So I'm just going to try doing this like one at a time. Just wait one more second here. So somebody give me an input number to work with. Okay, 2. Here is where x equals 2, right here. So what's the output value for green? 0. Output value for red? 3. So 0 plus 3 is? Okay. Let's try it again for new input value. So let's do it for the next one over. Let's do it for 3. This is 1. This guy here is, what is that, 5? So 1 and 5 will give you 6. Okay, this one's 2. This guy is whatever it is, so I guess it'll be up here, I think. Lost you guys?
It's just kind of confusing because you have got cards.
Fair enough. Maybe just watch me do it for now then.
All you do is
All I'm doing is adding the outputs. Okay? So maybe just watch this one here. This guy's output is 1, this guy's output is -1. Okay, so we'll be at 0. This guy's -1 and -2. Okay.
it just makes a new graph.
It's making a new graph, isn't it?
Oh, okay.
Okay. Now after a while, I think a couple of you guys are starting to pick up that this new graph is a linear line, isn't it? Well, could we figure out the slope of this graph? I think some of you noticed it already.
3x minus 3.
Yeah, it's 3x. And Conlon, where'd you get the -3 from?
I was just comparing the equations.
Sure, go ahead. But yeah, where did the -3 come from though? Yeah, the y-intercept, hopefully you guys can see it's at -3. There's our equation. Now, here's the point I want to make. Could I have gotten that equation a little faster? Just add the two equations. What happens if you literally took 2x minus 1 and added x minus 2? That's 3x minus 3. Does that make sense?
Yes, that makes sense.
I'm going to try this a few times, okay? I think repetition will just make it sink in.
My brain gets hung up, and I think this is just like, this can't be solved, but like my brain gets really hung up on the h of x, f of x, g of x.
So it's just a way of keeping track of which equation is which. Because we have 3 different equations. So we just use like f for one, g for another, h for another. But it kind of means the same thing. It just means it's a function. So ultimately, all of these just mean y. Like y equals, y equals, y equals. They're just all different y values. Okay. Here I'm going to give you some equations here. Can we figure out the actual like y equals equations for these guys? So like for the blue one, what's the equation for the blue one? Let's go blue first. X plus 1? Okay, and what about this guy down here? Are we in agreement on that?
Well, then when if we do -3?
You look at me funny. So figure out the slope. Yeah, the coefficient is 1 because there's a slope of 1. Remember that slope stuff?
So that doesn't mean it's just a straight line now.
Ah, okay. So let's do. You're with me here, but let's do this point by point again. Only the difference here is we're going to subtract them now rather than add. Okay. So we got to make sure we know which one we subtract. We take blue and we subtract red. Kayla.
How can you tell if you're going to subtract the equations or add the equations?
I'll tell you.
Oh.
I'll have to tell you. Good question. I will have to tell you what you're doing.
Cool.
Then switch the graph and do
Okay. So let's try them point by point. What do I say? Blue subtract red? Okay. Here's a good one. 1 subtract -3. 1 subtract -3.
-4.
Positive 4.
Oh, yeah.
1 subtract -3 will give you positive 4. Okay. 2 subtract -4. Positive 6. 3 subtract -5.
8.
Positive 8. I'm running out of room up here.
So 8, 10.
Okay, so let's go backwards. 0 subtract -2 is 2. And this one's kind of interesting. where they cross, -1 subtract -1 is 0. Okay, so I'm getting a line out of this again, aren't I? So again, back to practicing our linear lines. What's the slope of this line? Yeah, and our y-intercept? Now let's prove that by taking these two equations and subtracting them. So I'll just put them on top of each other. X plus 1, and we're going to subtract -x minus 3. So what is x minus -x? 2x. And 1 minus -3?
2x or is that a 3?
This right here is a 2. Makes sense? X minus a -x is 2, and 1 minus -3 is 4. Getting better? Does it seem stupid?
Yes.
Okay, good. Means we're doing it right. Okay, the point here is that we can take two different functions and add them together and make a newer function. Probably, but my point here is this is how we're going to make bigger powers. Because when we're adding a linear function to a linear function, it stays linear. What happens if we take a linear function and times it by a linear function? Does that make sense? So maybe I'll skip ahead to that. Okay, let's do the same one here. Let's times these by each other instead. So skip ahead here. Just do it point by point. What is 1 times -3 going to give you? Okay, so it stays there. 2 times -4. Okay, I'm running out of room already. Sure, let's go the other way. 0 times 2. 0. Sorry, 0 times -2. Sorry, my bad. 0 times -2 is 0. -1 times -1? Positive 1. Here, this will be a 0 times a -2. Ah, good. This is the thing I was hoping you'd discover here. Is after a while, what's happened here is we've taken a linear line, timesed it by a linear line, and made a quadratic. And that's how we're going to make cubics and quartics and stuff like that. It's really the result of timesing things to each other. Now, if I could, I want to find you the equation of this parabola really fast. Okay. The equation of the blue line, I believe, was x plus 1. The equation of the red line was -x minus 3. To find the equation of the parabola, it's going to be y equals bracket x plus 1 bracket -x minus 3. And just times them by each other. Does that make sense?
Is this as complicated as you said?
Well, dividing is the worst one. Dividing is kind of weird. But timesing hopefully is kind of making sense now. We could FOIL this out, by the way. -x squared minus 4x minus 3. Is that the equation when you FOIL it out?
Oh, I did it wrong. Round up the negatives.
So the point I want to make here, basically, if it seemed kind of silly at first, what we could do is take all of our y value outputs, we could add them together. We could subtract them together. But really, it's kind of boring if you're doing like linear plus linear, still gives you linear, right? But if you do linear times linear, it gives you quadratic. And so eventually we can start doing things like, what would happen if you took a quadratic and timesed it by a quadratic? You would. You get a quartic, because it would be like to the power of 2 times the power of 2 would go to the power of 4. Okay. Okay. Should we try another one? I just example you guys to death. How about you guys try this one? I do this one? You guys try or me try?
You should do this one.
Okay, how about you guys try this? Here's what I want you to do. Sketch this graph. Sketch this graph, then times them together, and sketch the graph after they're times together.
I'm already confused with this.
See if you can do all three.
F of x equals 0. How do you
What does f of x equals x mean? What graph is that? Should I do it?
Wait, it's just
X with this.
There's a straight line.
No, it's this graph right here. Because that's basically, I'm telling you what 1y equals x. It's this graph right here.
Because there's no.
Oh,
The constant is 0. So maybe do it by point though, because it's easier to do by point than draw like the line in. So like draw it like this maybe. There. Alright, so there's the graph y equals x. Can you guys handle 2x minus 2x plus 2? Okay, and then take all of the points, times them by each other, and it should make you a quadratic. Hopefully, if you do it right. So I'll give you guys a chance to try that. 2 is the y-intercept.
That's what I meant.
Okay, you're okay with this first graph? Okay. Negative 2x plus n go down to 2. And it has a slope of negative 2. So it's like rise to
Wait, we multiply x by negative 2.
So now I want you to take all of the multiply x by times by 2. So for example, like right here, 2 times negative 2. Yeah, so you do it like that. You do that now? You should get a quadratic if you do it next time. Basically, that's how you get the equation for it. So like try to find the points using just now. So you go negative 2 times positive, it's going to be negative 4. Put a new point down there. Try 0, 2 should give you 0. Like make me a new graph, which should be that quadratic. Give me 1 second.
Would you say x times x?
Yeah. Over 1 down to
Don't start so low.
Yeah, it makes
Okay, so let's take some of these points then. Where's the point at 2? Here's the point at 0. We may need a little more detail. Okay. I'll do it on the board here. So the other graph has a y-intercept of 2. So like right there. And it has a slope of negative 2. So like negative 2 slope means over 1 down 2, over 1 down 2, over 1 down 2. Does that make sense?
I used to have
Negative 2 right here.
I used to have way less. I used to
Over 1 down 2.
I used to roll it.
Because it's 2 over 1, it's like rise over your run. So negative 2 over 1 is your rise over your run. And this plus 2 is your y-intercept right here too. Okay. Guys, are you able to get these two linear graphs? Can I just do it up here? It's probably easier. Okay. If you guys are okay at sketching linear graphs, which we need to brush up on, I think. Okay. All I want you to do now is take the two different y values, times them together. What should you get when you do that? You should get a parabola quadratic, yeah. So let me try this here. 0 times 2 is 2. No, it's not. 0. That's bad. Okay. And this one will be 0 as well. This guy will be negative 4. This guy will be negative 12. Already off the page. Okay, I'm going to take, like, say, this dot right here. It's at 4. This dot down here at negative 1. Times them together. So it's at negative 4. Take this dot here, which is at 6. Take this dot here, which is at negative 2. Times them together. Negative 12. what you end up discovering is you get a quadratic. Does that make sense? It should give you that parabola, right? If you took and made it x times negative 2x plus 2, which is negative 2x squared plus 2x, that is that parabola.
Okay. Yes.
I just need to like get a pencil and knives now.
How are you guys doing?
Horrible.
And
Hey, you can pull.
good.
I think I can figure it out.
You got that? Okay. Always the two y values. Well, you just got to pick the consecutive ones, right? So like I picked this one times with this one, and this one with this one. They have to have the same input. So if the input is an x value of 2, those y values have to get multiplied together. Okay. Bring it back together, guys. Basically, here's what I need you guys to be able to do. You need to be able to add, subtract, multiply, and divide graphs. Okay? And it may sound kind of silly. I mean, maybe it kind of is kind of silly. The hardest one is going to be dividing. I promise you, dividing is going to be the one you're not going to like the most. Because there's a problem. The bottom of a fraction can never be 0. And that causes some funky looking graphs. So I want to walk you through a dividing by one here. Let's do these equations first, though. Let's say I gave you this equation here. What kind of equation is this guy? Okay, and if we took a linear graph, this notation basically means multiply them. So here's how that might look. Take x squared plus 4x plus 3 and multiply it by x minus 2. How do I put this in the standard form? Basically, you got to do a big crazy FOIL. So I'd like to show you a method for foiling some of these particularly tricky ones. This is the way I like to try it. First, you got to times the first by first. So x times x is, or I guess, x cubed. And then go this guy times that one, which will be 4x squared. And then go 3 times x, which is 3x.
And then put it underneath.
Okay, and then I still have to do the other one though, and I'm going to put that underneath. So then I'm going to go this guy times the negative 2, which is going to be negative 2x squared. This guy will give you negative 8x, and that guy will give you negative 6.
That's terrible though.
What's your last step?
Subtract. Let's combine them.
Yeah, put it all together.
X squared, x cubed, plus 2x squared. Minus 5x.
So, how do we divide?
We'll get to divide. Kind of. Yeah. Okay. Everybody okay with multiply so far?
Yeah.
Okay. Let's do divide. You're not going to like divide. I know. Can I erase this?
Is that all we do?
Pretty much, because our goal was basically to foil these two guys into each other and get our
Wow, that was
our equation.
that one was.
Okay, now let's divide. Divide's the one you're not going to like. Okay. First thing I got to do is I got to figure out who gets divided by who. Let me give you an example here. Is 10 divided by 2 the same as 2 divided by 10? Okay, so order is very important here. So if I do f divided by g of x, I got to write the f on top and the g on the bottom. That make sense?
Why have the bracket?
So is this one of those things where you kind of have to like get rid of that?
What's that times x?
Sorry, where?
Like it says
Oh, this right here? Okay, so what this means here, this notation here, means take f function, divide it by g function. And then the x afterwards just means that x is the variable you have. So what it means is take whatever your f equation is, divide it by whatever your g equation is, and this x here just lets you know that x is your variable.
Oh, that's so it's just
Just sitting there, it's confusing.
I know.
You have to like make it a major. You have to like.
Do we have to like get a common denominator?
Ah, okay. Couple of different things here. Common denominators will come later, but you said a word that's really important here.
Factor.
It is possible to sometimes factor things, and this one is factorable. Do you guys know how to factor the top of this thing?
X plus 3.
Yeah, and I'm going to show you where that can become useful in the next example, but this is probably the best way of writing it in a factored form like that. That make sense?
and that's done?
We're going to call that done for right now,
Oh. For now.
because my next example I'm doing something purposeful.
So when I'm done, I'm like halfway through.
No, we're done on that one. We're not coming back to it. That one's done.
Yeah, we
Okay, here's my question. Can we divide anything?
Because you've got to divide.
You really can't necessarily divide some numbers by each other evenly. Does that make sense? Like if I gave you 10 divided by 2, it does divide evenly. But does 11 divide by 2 evenly? And that's the same problem we have right here. Can we really do any sort of division right now? And the answer is no, we're not going to do it right now. Okay. Can we do the other one here then? What happens if we do g divided by f? What does that look like? It's actually just flipped around. Yeah, it's the x minus 2 on the top and these guys on the bottom.
So it's a negative.
So it's upside down. Do you guys remember what it's called when you flip something upside down? Good. Yeah, it's called a reciprocal.
I know.
Okay. Easy so far?
Yeah.
Okay, let me do the purposeful example now. I'm going to come back to that slide. We're going to try to sketch this guy divide by this guy. Now, I'm going to do this differently than we did last time, though. I don't want to actually like do it point by point because hopefully we discover that's taking a lot of our time, right? So let's actually try to figure out what the new equation is. We're going to do f divided by g, and then x is our variable. So what's our f equation? That one there. Could we FOIL this or factor this guy, though?
Yes.
What does it factor to?
7 and 2.
It does, actually.
Oh my gosh, I can pull that out of there.
And we'd then be dividing by the g one, which is x plus 2.
Wait.
And I've chosen this one on purpose, because can these guys actually divide by each other? Okay, now this may seem crazy, so this makes sense. Linear times quadratic goes up to cubic. What happens if you take quadratic and divide by linear?
Linear.
Like it goes back down again. Does that not almost make sense? Okay, like in terms of powers, right? Like if you had to the power of 2, it would go up to the power of 3 if you times them. But if you divide, it could like come back down to the power of 1. Because what I've essentially made here is a graph of x plus 7. Does that make sense? I can graph that really easily. X plus 7 has a y-intercept of 7 and is a straight line. Ta-da! Problem solved.
Okay, so then when we get something like that, we don't need to sketch the first two graphs.
Why bother? To be honest, from now on, really sketching the first 2 graphs was, I only did that for the first couple examples. It wasn't necessarily, like it's not efficient. Does that make sense? But I hope it helps make sense as to what we're doing, like explaining why we did what we did. From now on, really, we're just going to take the equations. We're going to either multiply, divide, add, or subtract them, and then that's our new equation.
So you're like quadratic divided by linear goes back to linear.
Yeah.
Linear times linear, that makes quadratic.
Does that make sense?
So if we like cubic divided by quadratic, they go to linear.
Exactly. You see how that works? Okay. There's one problem here, and you can follow along in your calculator if you want, but I'm going to type this in my calculator, and I want to show you something that's like something, tricky, I guess. Type this in here. If I go bracket, what was the equation? It was like x squared plus 9x plus 14.
Yeah.
And I divide it by bracket x plus 2. Just like, let's say you want to check your work, right? And I go graph. Does it look like I'm expecting it to? It does. But there's something hidden that your graphing calculator might not show you. I'm going to go to your table. And something shows up there.
Where you equal 0.
Error.
There's an error right here. And you'd think, well, hang on, why does -2 all of a sudden give me an error? Like everything else works perfectly. Anyone have any ideas why -2 doesn't work?
Why is 0?
Because y is 0.
Because we can't divide by 0.
Go back up here. Before we canceled away the x plus 2 right there, if I tried plugging in -2 right here, -2 plus 2 would have given me 0 like on the bottom of the fraction. And I can't have 0 on the bottom of the fraction. Does that make sense? So here's the twist that I just need you guys to remember. Dividing, so long as they actually divide, it's actually not really that hard, with one exception. Whatever canceled away on the bottom, that can't be used. Okay? So here's how we do that. At -2, we draw an open circle. And what the open circle implies is that that number is not allowed to be used. Okay? We call it a hole in the graph. Because there's like one number that just is not possible to use. Does that make sense?
Yes.
Okay.
Does that just happen when you're dividing though?
Just when you're dividing. Because you can't divide by 0.
Because it's the one that we crossed out.
Yeah. But here's the thing. In the original thing, though, before we crossed it out, -2, you can't divide by negative. Like, you can't divide by 0. Does that make sense? Because, like, if you try to plug -2 down here, it would give you 0. I know we're trying to cross it out, but
Oh. So you have to do the opposite, like you just reverse the sign?
yeah, reverse the sign again, right?
Okay.
Can I go back a slide here? I'm not going to add to this here, because I promised I wouldn't, but what number is there going to be a hole in the graph for based on this one right here? +2. What number is there going to be holes in the graph for on this one? Make sense?
I get it.
Okay, good. Okay. I just kind of threw on here a picture. Our goal is going to be to eventually, guys, sorry, I know I'm talking a lot. We're back to school. My goal is to show you guys all sorts of different functions over the course of the year. And some of them you guys kind of know already, like linear functions, quadratic functions, constant functions. Eventually we're going to learn some other type shape ones. Okay? Here's my point. When you combine functions, they're going to become other function types. That makes sense? Like linear becomes quadratic if you multiply. But if you do like cubic divide by linear, it becomes quadratic. That's my point today, is we can then make new functions by multiply, add, divide, subtract, whatever. Okay. Here's a picture of like what I just showed you guys. If I gave you the graph x squared minus 1 over x minus 1, do you guys remember how to factor x squared minus 1? What you call that?
Do we remember?
Difference of squares.
Yeah.
Okay. So this would become x plus 1, x minus 1 over x minus 1. Do you see how something could actually divide? Well, x plus 1 is a nice straight line, with one exception. You can't plug in 1 on the bottom here. So there's literally, we call it a hole in a graph. Okay? There is only one number that doesn't work, the number exactly 1. 1.01, that works. 1.02, that works. That makes sense? But like literally just one number is not possible to use. 1.00000 is the only number that we can't use. Here's where that changes things. What's the domain of this graph?
Oh no.
So anything x is low.
X
So x is an element of
not
the real
It can't
greater
be.
than.
Cannot
X
equal
cannot.
one.
Yeah, X.
That's pretty much, here's the best way of putting it. X is an element of the reals, but x cannot be, and this is probably the first time I've given you an example of a graph where the domain is not element of the reals just by itself. There's like literally one number that it can't be. Does that make sense? And so the only reason that would happen is, so far, because you're dividing two functions. That makes sense?
This is only when you're dividing the function.
So far. We're going to pick up new reasons later, but for at least what we're starting with, yeah, if you divide functions, your domain is no longer everything. So you guys want to try one on your own? And I think I made a typo on this one here. Make this x plus 1. Make that x plus 1 there. I think I typoed that one because that factors to, yeah.
Like what's free? It's like, but you didn't sure you didn't make money in a year. In a year.
I didn't know which one's 3.5.
Didn't I tell you?
Oh.
I will have to tell you that. It's a good question. Yeah. Numbers that add to give the middle number, times to give the outside number.
8 1. X plus
Yeah. Times to give the outside, add to give middle.
How do I do it? Oh, that's what you
Yeah, I changed it to 1.
guys are mixing that part.
What do you mean switch the signs? We don't switch the signs, but the hole in the graph is the opposite of that.
I'll probably get like.
Does that make sense? So like the number that we can't use, like say it's x plus 1, negative 1 is the number we can't use. Does that make sense?
Do we get money in this year?
We better.
No, we used it all in our budget to get through school.
What?
Alright. So you guys able to factor this?
Yeah.
Oh wait.
So now we just need to, can we cancel?
Yes.
Alright, so we do. Here's my equation.
I cancel.
Oh, okay. Can I do that one next? You're a little ahead of me, but that is actually my next point.
And this
Okay. So here's my graph, x plus 8, so it'd be up here. So let's say I drew that nicely. Would that be drawn correctly though?
No.
Okay. Convention is you have to like very distinctly draw the hole in the graph. So the hole is at, again, negative 1. There.
Wait.
How do you?
Why is it 1?
Oh, it's you can't.
Because the thing we canceled away, even though we didn't cancel it away, before we did that, negative 1 can't go in here. Because negative 1 plus 1 will give you 0 and you can't divide by 0.
So we don't get these ones in this year?
Basically, we'll do it in the next year. You guys okay on this slide? Okay, Aiden, your question. When dividing polynomials, unless they divide evenly, we can't do it basically. Now, okay? In order for it to remain a polynomial function, it has to divide evenly. In our non-polynomial functions unit, we'll do something like this. This guy right here can factor to x plus 5, x minus 4, and what's this guy gonna factor to? 6 and 3? X minus 6, x plus 3. Do these guys actually divide? Okay, here's my promise to you. In this unit, we won't do this. In the next unit, we will. That make sense? Because this technically is not a polynomial anymore because it didn't like actually divide evenly. Does that make sense? Can I wait till next unit? Sorry, bite-sized pieces.
Yeah.
Let's stick to this.
Okay.
Let's just make it work.
So we could still do this by doing like literally like point by point if we wanted to. So I mean we could try that again here. Like here's two graphs, let's try dividing them. Point by point. So take the blue graph and divide by the red graph. Let's see maybe what it looks like. So like for example, here's 1, divide by negative 3.
That's so messy.
Yeah. Take 2, divide by negative 4. No, negative 2 divided by negative 4. Negative a half.
This is.
3 divided by negative 5.
Isn't that
Okay, here's my point. What would the equations of these guys been?
Horrible.
Well, aren't they the ones we've been doing before? This is x plus 1, and we're trying to divide it by negative x minus 3. Do these guys divide? Okay, here's the reason why we're leaving this for later. It's really stupid, because you're going to get all these decimal numbers and stuff here, and so this is still possible, but does that make sense why I want to leave it till later? Because dividing numbers, unless they divide evenly, like 4 divides by 2, that works. But what about 7 divided by 5? That's stupid, right? You still would actually get a gap, true, yeah. But we're gonna leave that one till later. Does that make sense? So that's the reasoning why. Is this graph right here is we'll get to it later. Okay, so here's my promise. Whenever we're dividing things, they will factor and they will cancel. Okay, at least in this unit. Next unit we'll do the stuff that doesn't cancel. Okay. Okay. You guys have any questions? Did it make sense by the end of the day? You kind of get the concept? Okay, summary. I need you to be able to add, subtract, multiply, divide things by each other. That's it. Okay. Okay. You guys need some practice on this? Okay. There's two different sections in your book. I'm not usually going to put up like question numbers to do. My opinion is more, here, I'll tell you where the questions that are in the book are on. I don't care which ones you pick. Just pick and choose some to try, okay? So here's some places to take a look. I know I'm kind of jumping around the textbook here. Call me around. I'll come give you guys a hand, okay? But probably not a good idea just to sit here and do nothing for 15 minutes. Try something still, okay? Sure.